Good afternoon, class. In this video, what I'd like to do is to go over an example for how to deal with atomic symbols and how to gain the information that you need from it just by looking at the example. This actually comes from polyatomic ions model 3 from the homework, so if you want to follow along from there, this is where I got it from. What you'll notice in here is I have aluminum carbonate. I've also gotten I wrote down some of the compound numbers, and then this extra compound, or this extra number here, whatever that means. I've also put their charges here just to show you that when we deal with polyatomic ions, they are balanced, and they always seek to be balanced in terms of the number of charges. So, and also as an aside, you can tell a lot of times based on these numbers here what the charge is of the particular cation, because especially, I mean, with aluminum it's not as much, but things like, especially with iron, whether it's iron 2 or iron 3, that actually matters, and you can tell based on what this number is. And the reason you can tell that is because every charge seeks to balance itself out. So what you do is you look for the number of number here, and what you do is you find the least common multiple of it, and that's the total amount of charge within the whole atom, the total number of negative charges on one side and total number of positive charges on the other side. And when you figure that out, you can figure out how much charge there is. So in this case, 2 times 3 is 6. So the total charge must be 6. So that means this aluminum, because there's only 2 of them, must have a 3+ charge. And the carbonate, because it's 3 over here, must have a 2- charge, which checks out with the polyatomic ion chart that you've been given. So what I'd like to do is also point out why I have them in different colors. So in this case, the green box tells you that it is attached solely to this element right here. So aluminum has 2 aluminum atoms in this aluminum carbonate. However, and I will continue over here with the oxygen. The 3 tells you that this 3 is attached to this oxygen right here. Therefore, there are 3 oxygen atoms in the carbonate polyatomic ion. However, as you notice, there's a parenthesis here, and then there's another number right here. This number is in blue, and the reason why I distinguished it and why it doesn't match up with the color scheme I had in my last video on atomic symbols, the reason I did it was to highlight the difference, that this number is very different from this number. Okay? And the reason why is because it is outside of the parentheses. So what that means is that in this aluminum carbonate atom, what happens is you need 3, not oxygen atoms, or not 3 carbon atoms, but you need 3 carbonate molecules to balance themselves with the aluminum cation over here. So 3 carbonate anions to balance the 2 aluminum cations. So that's where the balancing act has to occur, and that's why there's this 3 over here, because it helps to show you how everything gets balanced out. In future videos, what I will do is I will show you when we get to chemical reactions how these numbers, and these numbers actually really play a big role in figuring out how to balance chemical equations. So that concludes this video. Good luck in your studies, and may the force